Here's our pre-lab for Lab 9, and I think you'll find this lab refreshing. I mean, so far you're probably frustrated with yourself over the oxygen lab, and you're wondering about that huge error that you got with the Avogadro's number using Cinnamon Lab, and you're looking for something to ease your way out of here. And here's your answer to your prayers. It's Lab 9. Lab 9, I think you'll actually really enjoy, at least relatively speaking. This one's a little bit more fun. And we're looking at acids and bases. So drink orange juice after brushing your teeth. Yeah, it tastes terrible. If you really want to do that, go ahead. Be my guest. It's not really that lot. It's not a whole lot of fun. But brushing your teeth, yeah, it neutralizes. Has this reaction. It tastes terrible. But let's talk about acids and bases. Acids and bases. Acids have hydronium ion in them, at least in water, forms hydronium ion, and bases, oh here we go, bases form hydroxide ion predominantly in water. And pH is the minus log of the hydrogen ion concentration. So here's pH. So if you have the hydronium ion concentration, it'll take the minus log of that and give you the pH. And here's some pH of some common foods and stuff. You can see here most foods are slightly acidic. Anything less than 7 is acidic, greater than 7 is basic or alkaline. Here with the word alkaline, that means basic. And there are a few things. Acidic things tend to taste sour, so you can see here that a lot of these things, a lot of citrus things taste sour. So lemons and limes are very acidic, very sour. Vinegar is not on here. It has a pH of about 3. That's also very sour. So tomatoes, apples don't taste too sour to me. I guess because they're so sweet. Tomatoes are pretty sour. Things that are greater than 7. There's not very many foods that are bases. There are a few things. Medicines tend to be basic, so that's why. And things that are basic taste bitter. So like bitter. So like, I mean, cough syrups, that kind of stuff taste really bitter. That's because they're basic, and some roots will be kind of basic, but not really many things are basic. Another hint with basic things, they tend to feel slippery. So things like bleach or laundry detergent and soap, those are typically basic, and that's why they feel slippery. Not everything that's slippery means it's basic. So motor oil feels slippery, but motor oil is not basic. It's neither acidic or basic. It's an oil. Only things that are water-based are acid or base. And but base, something that dissolves in water, is water soluble, that feels slippery, is a base. Typically, I should say. And we're also going to use pH paper. So the litmus paper, if you, depends on the type of paper you have. There's certain colors that they have. I've typically seen in these kits to have the various scales. There's also red litmus paper that turns blue in a base, and a blue litmus turns red in acid. And so neutralization reaction, that's one when an acid-base react and form a salt. So strong acids you'd expect to have a very low pH, a 0, 1, or 2. Sodium hydroxide, strong base, you'd expect that to have a pH of around 13 or 14, really high pH value. And you do want to wear eyeglasses for this, wear gloves. Eyeglasses are really important. They're important for all the experiments, but you do not want to get acids or bases in your eyes. It doesn't feel very good. And if you get anything in your eyes, like if you don't wear eyeglasses and you get something in your eye, just rinse it out really well for at least 15 minutes in the shower or in the sink or something like that. And if it still hurts, go call a doctor. It's really important to protect your eyes. I can't think of any profession that people do better. It's an advantage for blindness. So please watch your eyes. And here's the materials you need. And first thing I do is look at grape juice. So you're going to take Make a 10% grape juice solution by taking 5 milliliters of grape juice and then mixing that with about 45 milliliters of water. Don't measure it, just pour the water till it gets to be 50 milliliters. And you can be a little off. It's not. This doesn't have to be super exact. You're just using this as an indicator. An indicator is something that indicates by a color change an acid or a base. And then you have 3 test tubes. One you do nothing to. One you put citric acid in, and one you put sodium bicarbonate in. So this is baking soda, sodium bicarbonate. And if you don't have enough grape juice, you can add a little bit more. So you can add a little bit more, especially for the base. And why the base? Well, this is not said here, but water does not have a pH of 7. Pure water doesn't. Well, pure water does, but here on Earth we have carbon dioxide in the atmosphere, so pure water typically has a pH of around 5.6. So water just sitting there, if it's water, nothing else, is going to have a slightly acidic solution, so that's why you might need to add a little more base. And so these types of things. So now add the acid, add the base for test tube 1, and then you sit still, and then test it with the pH strips, and then from that you can get the pH value. And then for the neutralization here, for test tube 1 has a citric acid, you're going to add sodium bicarbonate. And you keep on adding until basically they all look the same. In test tube 2 you add acid and check the pH of them, and they should be well in the same range. And so test some household product. You can test more if you want. This is where you use your 12-well plate. And my students seem to really like this lab. And so you hypothesize a pH. Hey, you can be totally wrong. Hypothesize is an educated guess. So guess what you want. How do I guess it? Well, here's a hint. You have this chart up here. So you can check different things here. So kind of, have a guess there. Well, drinking water, I told you that it's typically a little bit lower. Well, depends on how much carbon dioxide you have dissolved in it. And ocean water, for instance, is slightly alkaline. It just depends on where you're at. If you collect rainwater here in Hawaii, we have terrible acid rain. The pH of the rain is going to be on the order of 4. So we have really bad acid rain. So if you want to grab some rainwater outside, you can see how terrible acid rain we have. And then you look at the color litmus paper, color the pH paper, and then you can get the actual pH. You get that from the color of this. If you are colorblind, and try your best to use the grayscale, or you can have somebody help you out, or talk to me, we'll figure something out. But usually people that are colorblind still can tell by grayscale things. So this is something you should, with color blindness, you can still do this experiment because of, you can kind of tell by the shades, and typically people can especially see the blue, so the basic side's gonna be better. Although I'm not talking from experience, I happen to not be colorblind, so I really don't know. But if you run into any issue, please let me know. And why did the grape juice change color? So grape juice has an indicator, and a couple foods have indicators in it. Red cabbage also has an indicator in it. And the acid and or base react with chemicals in the grape juice to cause a color change. So that's you can tell right away what's a good guess of whether something is acidic or basic. And why did it turn original color? Well, I just kind of said why. And 2 acids, 2 bases you often use. So I remember before, things that taste sour are acidic. Things that taste bitter are basic, but not very many things taste bitter. And even things that we consider to be bitter, so bitter melons oftentimes are acidic, not necessarily basic. Even though they say bitter melon, I've played with them, I've tested them, and I've always come out basic or acidic for me. Maybe you do have a bitter melon that's basic. If you do find one, let me know, because I have yet to be able to find one yet. Soaps tend to be basic. Detergents, this kind of stuff, are typically basic. Well, they add basic things to them to make them work better. So detergents work better in basic environments. And then you're done with your labs. So if you're doing them in order, lab 9 is the last lab. So uh, fill out the sheets and turn them in, and let me know. Hopefully you've enjoyed this exploration in chemistry from the comfort of your own home. And please remember safety always. And once again, hit me up if you come up with any issues.